In this video, we are going to learn about circles on the coordinate plane. First, we'll talk about the equation of a circle, where it comes from, and then we'll do some examples of how to write the equation of a circle, graph a circle, and look at the different forms of the equation of a circle. So the first big question is, what is a circle? We all know what they look like, but do you know the definition of one, right? A circle is obviously round. It doesn't have any corners or vertices. But the thing that makes something a circle is that all of the points on a circle are the same distance away from the center of the circle. And that distance from the center to the outside of a circle, as we know, is called the radius. So in a circle, all of the points on it have to be equidistant from the radius. So the definition of a circle is a collection of points equidistant from a center. Remember, equidistant means the same distance. This is the difference between a circle and, say, an ellipse or an oval. They're both round. They both don't have any vertices. They both have a center and a radius, except in an ellipse or an oval, all of the radii are not the same length. That's why an ellipse is not a circle, because all of the radii are different. So the equation of a circle actually comes from the distance formula. We just talked about the fact that all of the distances on the circle are the same. So that means that all of my radii are the same. So I can use the distance formula to write an equation that would express the length of the radius. Remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, as I just said, the distance here between the points is my radius, so I'm going to replace d with r. And then I'm going to plug in the points from this picture here, where h comma k is my center, and x comma y can represent any point on the circle. So we have x minus h squared. Those are the two x values of my coordinates. And then y minus k squared. Those are the two y values of the coordinates. Just to clean this up now a little bit, if I wanted to get rid of the square root symbol, I could square both sides of my equation. The square root and the squared would cancel out because they're inverse operations. And I would just be left with the equation x minus h squared plus y minus k squared equals r squared. This is the equation for a circle on the coordinate plane, where h comma k represents my center, and r is the radius. Now you will notice that the signs here are minus. This is x minus h and y minus k. So that tells me that I always need to use the opposite sign when I am either writing the equation of a circle or finding the center from the equation. Because there are minus signs in the equation, that tells me that I need the opposite sign for the center. And you'll see what I mean by that in 1 second. So here it says write the equation of each circle. I'm actually going to start with B. Circle B with center 0, 0 and radius 6. So we know that my standard form, standard form for my circle is x minus h squared plus y minus k squared equals r squared. So in this case, h comma k, that's my center, that's 0, 0. So h is 0 and k is 0. And I know that my r is 6. So I'm just going to plug in those values into this equation. So I would have x minus 0 squared plus y minus 0 squared equals 6 squared. Now I don't really need these zeros here, so I'm just going to rewrite this without them. And I'm also going to square my 6. So my equation would be x squared plus y squared equals 36. Let me write that again. Let's go back to the top now. Circle A with center 4, -2, and radius 3. So I know that my h comma k is 4, -2, and my radius is 3. So h is 4, k is -2. So when I plug them into my equation, x minus h squared plus y minus k squared equals r squared. I have x minus, now h is 4, y minus, now k is -2, and r is 3. So now I'm just going to clean this up. This minus a minus will now change to a plus. So x minus 4 squared plus y plus 2 squared equals, and 3 squared is 9. You'll notice here that my h comma k with the -4 and the 2 is the opposite sign of the center that was given to me in the problem. This is what I was talking about on the last slide, that your center in your equation is always going to be the opposite sign because of the minus signs in the standard form of my equation. Now I'm going to graph. So to graph a circle, you need to know two things about it. You need to know its center and radius. So I'm going to start by identifying the center and radius for each one, and then from there I'm going to sketch my graph. So x squared plus y squared equals 25. That tells me that my center is going to be 0, 0, because I don't have an h and a k value being subtracted from the x and the y. And then this is r squared, so that tells me that my radius is 5. So I'm going to plot my center first at 0, 0, and then I'm just going to go 5 in each direction, up, right, down, and left, and then sketch my circle. Make sure when you're drawing a circle, you try to make it round. A lot of times when we draw circles, can be kind of hard, and they end up looking like diamonds, something like this. That's not a circle, obviously, so just make sure when you do your drawing, you try your best to make it round like a circle. So there we go. There's my circle. Kind of looks like an egg, but that's all right. My next example, I have x plus 1 squared plus y minus 2 squared equals 9. Remember that your h comma k is the opposite sign of the numbers in your equation. So my center here is going to be -1 and +2. You have to take the opposite sign. And my radius is 3, because this is r squared, right? So I'm going to start by plotting my center, -1, +2. And now I'm going to go 3 up, 3 down, 3 right, 3 left, and then circle it up. Circle with center 1, 1 goes through the point 4, 5. Find the equation of the circle. So in this case, I'm given that my center, my h comma k, is 1, 1. So h is 1 and k is 1, but I don't know the radius. I only know another point that's on that circle. So to find the radius, I'm going to use the distance formula, and I'm going to find the distance between the center and the point. Because if you remember from our definition of a circle, all of the radii are equidistant away. So if this point is 4, 5, and this point is 1, 1, I want to find this, the radius, that represents the distance between those 2 points. So I'm going to use the distance formula to find the radius. So subtract the x's, 4 minus 1 squared. Subtract the y's, 5 minus 1 squared. So this would be the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16. So that tells me that my radius is 5. So now I know my radius, and I'm going to just plug my center and my radius into my equation. X minus 1 squared plus y minus 1 squared equals 25, because this is r squared. So there it is, equation of a circle. And one more example. This time I'm given the equation of my circle in what's known as general form. It is not written out in standard form. I cannot easily tell the center and the radius from the way that it's written. It is written in general form. So I need to rewrite my equation from general form to standard form. So I need to change this to be in the form of x minus h squared plus y minus k squared equals r squared. And if you remember from way back when we want to rewrite something as a binomial squared, which is what the x minus h, is that how you spell binomial? I don't think so. Okay? When you want to rewrite something as a binomial squared, you need to use the process known as completing the square. And in this case, because I have an x binomial that's being squared and a y binomial that's being squared, I'm going to need to do that process twice, once with the x coordinates and once with the y coordinates. So here we go. I'm going to kind of color code this, maybe make it a little bit easier to follow. So if I have x squared minus 4x, I'm going to leave a blank here because I need to complete the squares with my x coordinates. And I'm going to do the same thing for my y's. Y squared plus 2y plus blank. I'm also going to move the 44 to the other side. 44. And now, if you remember, whatever you add to one side, you have to add to the other. So I'm going to leave my 2 blanks here for myself. So to complete the square, that would be b over 2a, or sorry, b over 2 squared. So in this case, that will be negative 4 over 2 squared, which is 4. So I'm going to add 4 to this side and 4 to this side. And then I'm going to do the same thing with my y's, b over 2, so 2 over 2 squared, that's 1. So add 1 to here and 1 to here. Now I'm going to factor each one. So this becomes x minus 2 squared. Remember that the sign here has to match the sign here, and the b over 2 value goes in here. And I'm going to do the same thing for my y's. Y plus 1 squared. Remember, this b over 2 goes in here. This sign matches this sign. And now that's going to equal 44 plus 4 plus 1 is 49. So let me just rewrite that again so that you can read it. X minus 2 squared plus y plus 1 squared equals 49. That tells me that my center is going to be positive 2, negative 1, and my radius is going to be 7 because this is r squared. Okay, so let's plot that. So positive 2, negative 1, that's my center. Well, let me use a different color other than black. And then I'm going to count 7 in each direction. 1, 2, 3, 4, 5, 6, 7. And then sketch my circle. Okay. So that is my tutorial on circles. Remember, to change from general form to standard form, you have to complete the square.